Hello everyone, my name is Molly Mayfield. I'm a support specialist at RockWare. Thank you for attending this webinar today. In this session, I'll offer a quick overview of some of the options you have when dealing with stratigraphic units which are discontinuous across your project area. This particular case study is fairly simplified. We'll likely cover more complicated examples in future webinars. Here are the topics which will be covered. First, we'll look at the stratigraphy data and some of the assumptions RockWorks makes. Then we'll look at the types table where the units are defined. We'll look at the data as it's entered in logs and straightline sections and see how the rules apply to those. Then we'll look at some of the stratigraphic modeling options, and then finally we'll look at adding missing stratigraphic data to the database. Stratigraphic data is entered into the RockWorks Borehole Manager's stratigraphy table. Typically, you enter the depth to the top of the unit, the depth to the base of the unit, and the formation name. As we look at the stratigraphic data for some of the different boreholes, you'll see that the order for the formations is consistent between holes. Because RockWorks models stratigraphy using surfaces, the formations need to be consistent in order between holes so that the surfaces don't cross. And they cannot repeat within a single hole because the surfaces cannot wrap around on themselves. An important note here is that if your project's geology is not this layered, you can also consider entering the data as lithology, which does not have these same restrictions. The formation names are defined in the stratigraphy types table, which links to the stratigraphy data table. You can access the types table by double-clicking on the formation name, or by using the button at the top of the window, or using the project manager as shown here. The stratigraphy types table defines the formation names and other important information for modeling and diagram generation. The order number is very important for interpolating a stratigraphic model, as well as if you have missing data and want RockWorks to be smart about handling that in models, logs, and simple cross-sections. The order can be defined in integers or decimal numbers, and they increase from the ground downward. And as an aside, the order number is also used to represent the unit if you save a block model version of your stratigraphy model, which RockWorks does allow you to do. So limestone would be, for example, would be represented with a 3 and basement with a number 5 in the block model. There are some instances where the order is not important. If you have a deep petroleum project with lots of formations, for example, and if you only intend to create simple cross-sections and structure maps, then this order field can be disregarded, and we'll address this in a future webinar. The formation names can be whatever you like, though shorter is better for visibility in legends. If you change a name here, it will actually be updated in the data table for the wells where it's listed. If you delete a name here, you can request that the data in the borehole records be deleted, or you can even substitute another formation name. So this is a very handy way to consolidate misnamed formations. The patterns and colors are used to represent the formations in logs and cross-section panels. In 3D, note though that only the background color is used. In section panels, you can choose whether to display the colors only or the patterns and the colors. The fill percent column affects strip logs only. It can be set to a value of less than 100 if you want to display a partial fill in the stratigraphy column to show erosion. The density column is used if you want to convert volumes to mass in your 3D scenes and volume reports. You need to be sure that the density value you enter here represents the density of the material per cubic unit in your project, cubic feet or meters, and this value is up to you to define. The Show in Legend checkmark is used to include or omit the formation name from any 2D or 3D stratigraphy legends. Recently added to RockWorks16, this setting can also be used to omit formations from modeling, a handy feature if you have a lot of units but only want to model a select few. Let's take a quick look at this project's stratigraphy logs in 3D. This will give us a quick graphic and spatial look at the data as it's entered into the database across the entire project. The first step is to be sure that the output dimensions are established. This sets up the output space for the models and diagrams you create. Once you've entered your borehole data into the database, you can either type in the min-max coordinates for the axes, or you can use the Scan Boreholes button to have the program quickly compute the extents. So here I select the Strip Logs 3D Multiple menu option. Along the left here I'll set up the diagram options to include a reference cage and a stratigraphy legend, for example. Then over to the right I click on the 3D Strip Log Designer tab to define what items I want to show in my logs, and here I'll just choose the title and the stratigraphy column. With the diagram generated, we can hide the menu options and zoom into the view to take a look at the data as entered in the logs. As you take a look at this, you'll notice that the light blue C Leadville formation is present in the logs on the east side of the project, but not on the west side. And this is the unit that we're going to work at pinching out in this lesson set. So let's take a look at some of the data for these holes on the west side of the project so we can see how the missing data looks. So here's one hole. You can see that C Leadville's missing. It's here in this hole, and it's missing in this hole as well. And if we look back in the diagram, there's another hole I want you to take a look at, and that's the B40, which is actually missing a chunk of data from the middle of the log. And let's look back at that data and see what causes that to happen. And you'll see here that the base of the B unit and the base of the D unit are both missing from the data set. So let's take a look at how applying some of the stratigraphic rules, the inferring partial units, will solve that problem of missing data bases. So let's just rerun these logs now with the rules turned on. It'll regenerate the log display. And if we zoom into the B40, you'll see now that RockWorks has made the inference that the base of the yellow, it should be the same as the top of the blue. Here's some information about how these rules work taken right from the help messages. So the one we used just now was inferring partial intervals. And what will happen here is if there's a missing depth to top, RockWorks will assume that the top is equal to the base of the unit above. If it's missing the top of the hole, it'll assume it's set to the zero depth. If there's missing depth to bases, it will assume that the top of the unit below should be used. And if it's missing the depth to base at the bottom of the hole, it'll use the TD. So let's take a quick look at how simple straight line cross sections can be affected by the stratigraphy rules. In Strip Logs 2D section, I can turn on my logs by inserting a check here in Plot Strip Logs. I can tell it I want to plot easy correlation panels by checking this box. And I can expand the stratigraphy heading to choose that I want colors in my panels and to label context for partially defined intervals. I can turn on my stratigraphy legend. Here I'll choose what I want to have on in my strip logs, stratigraphy column, depths, and title. Here I want to turn off my rules, and here I will pick my section location. Note that the rules are always on by default, so if you want to see how the data is entered in your database as is without any inferences, you should turn the rules off. So zooming into the hole which was missing the base of that B unit, you see there's a lot of empty space shown here. The unit's not shown in the logs or in the correlation panels. So turning on infer partial units will then tell RockWorks to fill in that space. So let's regenerate the cross section. And now the program has inferred that the base of the yellow is equal to the top of the blue, and that the base of the brown, or the D unit, is the TD of the hole. If I now tell it to insert missing units here and regenerate the section, the program will know to insert the missing Leadville unit into proper sequence in this hole, and the panel will be filled in. Let's jump back to the help file real quick to see an example of what the Insert Missing Units does. Here's an example of where A, B, D, and E are present, the units. And what RockWorks will do is during modeling, it'll insert the top and the base of the C unit in proper sequence. It doesn't affect the data itself, it won't change your data, but will affect how it's processed during modeling. While the Straightline Crosssections basically connect the dots between adjacent holes, and the rules can help fill in blank spaces, let's see how the program handles this missing data during modeling. Creating stratigraphic models allows you to visualize the formations in 3D, build composite 3D scenes, compute volumes, and much more. We'll create the stratigraphy model and display it in 3D using the Stratigraphy Model option. And in this part of the demo, we'll recreate the model a number of times with different settings turned on to see the outcome. The process of creating the model involves creating a surface or grid model for the top and base of each stratigraphic unit. So you'll end up with 2 grid files for each formation in your project. We'll look at that in a minute. Just as a reminder, you can imagine a grid model as a grid of imaginary lines that overlays your source data points. During gridding, the program assigns a value to the grid line intersections, which are called grid nodes, given the data at hand. In the case of stratigraphy models, the node values represent elevations for that surface, and the data it uses is pulled from the boreholes, shown here in red. The grid models for all of the units will extend across the entire project area, even for areas where the units pinch out. And that's really important to understand. So the trick is to get the surfaces to lie between adjacent surfaces where they are pinched out, so we can hide them in 3D displays, so they won't be visible in 2D sections, and so they won't contribute to any volume calculations. The spacing of these nodes in the grid models will affect the accuracy of the models. The spacing setting is defined here in the Output Dimensions area. If you've used the Scan Boreholes button to set these dimensions, be very sure to look at the spacing setting that was assigned. If your holes are 25 feet apart and the node spacing here is set to, say, 100, then these grid models won't represent your data very well. Be sure to look at the node spacing. The range of the axis coordinates divided by the spacing gives the number of nodes. So let's run a 3D stratigraphic model now, and this first pass will do it with none of the rules turned on. In the Stratigraphy Model Options window, we'll be sure that Interpolate Surfaces is turned on so that RockWorks knows to generate the grid models. The Options button can be used to adjust gridding settings. The Strip Log Designer tab can be used to adjust the log settings, and here's where we turn off the rules. As RockWorks builds the stratigraphic model, it interpolates a grid surface for the top and the base of each stratigraphic unit that's listed in your types table. And these grid models will be stored in the project folder. And here's how the stratigraphic model will look once the grid models have been interpolated and the 3D scene has been built. And just for reference, I'm going to move this out of the way, and in the Project Manager, under the Grid Models heading, you can see the RWW grid files for the top and the base of each unit stored now in the project folder. In the 3D display, you can drill down to each formation, turning them on and off to see where they lie. And in this scene, you can see that the blue formation is heading west right through the middle of the brown unit because there were not enough control points to tell RockWorks where to interpolate that blue surface. So we're going to recreate this model, this time turning on the on-lap setting. And again, be sure that Interpolate Surfaces is turned on so that the grid models will be regenerated. On-lap is a rule which tells RockWorks to give priority to lower formations so that upper formations cannot dip below them. And this model actually looks much better. The on-lap caused the blue layer to lie on top of the lower brown layer. And this may be all that you need to do to place a missing unit in proper position. However, the only potential problem is that it relies on a good foundation, so if you have missing data for the lower unit as well, just draping the blue surface atop the lower one may not solve the problem. Let's try a new display option with these same grids to see how well the unit actually pinched out. I'm going to turn off Interpolate Surfaces to redisplay the existing grids, and I'll turn on the Hide Thin Zones setting under the Diagram settings. This tells the program that if a unit is less than a certain thickness, it should be rendered invisible in the 3D display. So let's see how this looks. I'll expand my model heading and drill down. And this looks much better. But there's still pockets of that blue Leadville unit where the surfaces aren't completely pinched out. So let's recreate the model again, now with the Insert Missing Units rule turned on. This is used to trick the program into inserting the missing blue unit in proper sequence along the west edge of the project. And again, it doesn't insert the data into the database, but it will add the necessary control points to the batch of points it's sent to the gridding process. And as we drill down now, we can see that the blue unit is missing on the west side of the project. There's still a bit of a ragged edge where the unit is pinching out, and I'm not going to go further with this at this time. There is actually an advanced stratigraphic modeling webinar which will talk about how to clip a unit exactly where you want it to be clipped. Let's jump to the cross-section display using these same surfaces to see how this looks in 2D section. I choose this Stratigraphy section menu option, and I establish these settings, being sure Interpolate Surfaces is turned off this time because I want to use these existing grids. I don't need to keep recreating them. My strip logs are still as they were, and I'll pick the same section selection area and generate the cross-section display. And we'll take a look at this. I'm going to hide my settings and zoom into the area where the pinch-out occurs. And that looks pretty good. One note here, sometimes you can still get small bands of materials where they should pinch out. This can be an artifact of distant holes influencing, however slightly, the elevations of the units. If you're using inverse distance as the gridding method, you can try reducing the number of holes to use in that interpolation, for example, instead of 8, to help reduce this. Let's create another quick cross-section through another area in the project and see how that looks with these same surfaces. So I'll hide the settings pane and the layers pane, and we'll take a look at how this pinch out looks, and it looks great. I'll close this window and we'll move on to looking at how to modify the source data itself. All of the settings and the rules that we've applied to the modeling have not even touched the source data. As we look at the boreholes, we can see that this unit C is still missing from these holes. And you can certainly insert a missing unit into a hole by just manually adding it like this. I press the down arrow at the bottom of the record, add the top and the base, choose the unit, and when I click away and click back, it'll be resorted and displayed right there in proper sequence at no thickness. If you have lots of holes, that can get tedious, so we have added a fill-in missing stratigraphy program option to the strip logs menu, and it will go through and, assuming your stratigraphy types table is in proper order, will insert units in proper sequence at 0 thickness. So that's it for this session. Thanks for joining us today. If you haven't already, please visit the RockWare channel on YouTube or visit our gallery on our website, rockware.com, for more webinar videos, instructional how-to videos, and other resources. Thanks for watching.